And then starting up here, we say equals. And let's do this all in one step, so we would say equals, oh, we need P star, right? Steps, find P star. Let's call this P star. P, and this equals 1 plus the risk-free rate minus the down divided by the up minus the down. And when you do this, just make sure that you have the parentheses there so that you're not just dividing the down by the up minus down factors, or you're not just dividing the top numerator only by the up factor and then subtracting the p. So close both sets of parentheses, and we see that in this case we have a 51.6% chance of moving to the up state, which gives us a 48.3% chance of moving down. And again, it's nice if we call this P, because what that allows us to do is look at our formula and say P, did I get P in? P times our up state plus 1 minus P, and notice the parentheses, times our down value. And now closing all the parentheses and then dividing by 1 plus the risk-free rate. And again, it would be nice if I name this something like RF, because then they're not going to drag. Anything that has a name doesn't drag. And so the only thing that's going to drag here is this H28 and the H30. And so as we drag down 2, we should get the appropriate formulas for all of these. Knowing that these zeros we just take out. Okay? Now, the other thing that we can do is, remember in Excel, if we copy something and then we paste, it's going to adjust the cells. Moving does not adjust, pasting does. So if we look at this, what I just pasted in here, and we just want to double check, is G29 the up state? Yes. Is G31 is the down state? Yes. So all I did was copy and paste, and then again I can just drag down. We know that that works now. And what you should see is that this number here by construction, right, this is the present value of the weighted average of these two numbers. So if you're not getting a number that's basically a little bit less than right in between these two, something's askew. Where was I? Okay, and just make sure that you have the right kind of combination here. Now, this tells us that given these parameters, our call value today is $9.58. Then the rest of the two questions for the first part, and that's where I'm going to leave off today because we haven't explained the black shoals. The rest of the two parts are basically only what happens if we change volatility. Well, if we change volatility, we know that volatility goes into both the up state and the down state, and the up state and the down state determine the probabilities, and all of that determines everything else. So all we really have to do is say, what if our standard deviation is 35%? You can see everything kind of changed in here. And again, we know that if volatility goes up, we end up with a higher price. The more volatile the option is, the higher the price. We can do some other stuff in here, right? What happens if, keeping the original volatility the same, if we change the strike? Well, the strike doesn't determine the up and the down states, it only determines the future payoffs of these states. So if we change the strike to 60, we can see that all of these values change. Now, this also makes sense. As we're more in the money, we lowered the strike to 60, so now we're $15 in the money, price increased. So all I'm looking for is your kind of substitution in there. You might want to mess around with this a little bit. Look what happens if the price goes up, right? If the price goes up to 80, the call value goes up. So calls are increasing in volatility, they're increasing in the stock price, they're decreasing in the strike price, right? If we, right now we're at 12.75, if we make this strike 100, we decrease. So decreasing in the strike price. Now these other two, this is a little less intuitive. Let's kind of go back to our original base case here. 25% volatility, strike and stock at 75, and let's look what happens. And again, I'm just going to do this so that I don't have to keep scrolling down. But again, nice way to clean up your work. Don't do it on this one because I want to see it, but when you're doing your own work, hiding your working cells is oftentimes an easy way to just make your worksheets look a little bit cleaner. All right, so what happens if we change time? Well, if we change time, we know that time enters up in here, in the square root of this exponential up here. So if we change time, and as we saw, we kind of expected that if we change time, this option price is going to increase. So if we make the time between periods 0.5 instead of 0.2, we end up with a higher price. Again, these are all just comparative statics. What happens is we only change one of our inputs. Back to our base case. And again, the risk-free rate enters only into our P star up here, right? This is our risk-free rate. So as we change our P star, as we change our risk-free rate, the numerator should go up. Well, if the numerator goes up, it makes a higher P star, leading to a greater probability of going up in the tree than down. So our expectation should be that this increases the probability of getting the higher prices. It should increase the call value. So if we change our risk-free rate from 1% here to 5%, that was a big jump, right? So here's also it's difficult, to say the least, to trade based on expectations of changing interest rates. You're not going to trade calls and say, I'm expecting the Fed to raise their interest rates. They're unpredictable at best. We know that they're not going to really change for the next 3 years, most likely. So not something you really want to trade on, but it's worth knowing how that increases price. So, at this point, you'd be done with the first part of the project. It's not too difficult once you get it all in there. And then again, with just some minor cleanup, you can spread these out and then put in some lines however you want to. And once you get one line, I would say just copy it and paste a whole bunch of them. You know, paste it there, and then paste it there, and so forth, because they're all going to be the same lines, the same length. Now, to the second part of the project. A note on continuous compounding. All right, so back to some of the stuff that we talked about at the beginning of the class 4 weeks ago. If your money earns an APR, and remember this is an annual percentage rate of 6% per year, compounded semi-annually, so that just means it's twice. The way that we figure this out is we divide our rate, our 6% by 2, because we're compounding twice, and this gives us a future value of 6.09%. general formula for getting the effective annual rate is we take the APR, divide by the number of times that we're going to compound it, then we actually compound it by adding 1 and raising it to the exponent of the number of periods, and then subtracting out the 1. As the compounding frequency increases, so as